Good morning, students. Am I audible? Okay, in the last class, we have discussed about Kennedy's theory, which is used to design a canal or channel of mobile boundary, or you can say irreducible boundary. Okay, so the second method we are going to discuss today is our Lacy's theory. Okay, so in our syllabus, we have two theory. One is your Kennedy's theory and one is your Lacy's theory to design irrigation canal or a channel, or you can say a drain of mobile boundary or erodible channel. Okay, so one you have Kennedy's theory and another method is your Lacy's theory. So Kennedy's theory we have already discussed in the last class, and it is an trial and error method, your Kennedy's theory. Okay, and in Lacy's theory we are discussing today. Okay, so you please write down the steps required in design by Lacy's theory. So I think the steps are visible. You kindly write it down, okay? Because when you solve numericals, these steps is required, okay? So to perform Lacy's theory, definitely we should know the discharge, okay? Okay, to perform Lacy's theory, we should know the discharge. Definitely for this discharge, we are going to design that particular canal, okay? It is also called design discharge, okay? Then we need bed materials, or you can say sand size of the bed materials, okay? And always remember it should be in mm, okay? So we need discharge, then size of the bed material in mm, then side slope, okay? One vertical is to z horizontal. So if it is not given, then we can assume half horizontal or one horizontal, okay? So z is equal to, you can consider zero point 0.5, z is equal to, you can consider 0.5 or 1, okay, or 1, okay? So you have two options. If you don't know the side slope means we are going to design for trapezoidal channel, okay? So the side slope it is not given, so we are going to assume 0.5 or 1 if it is not given, okay? So the first step, from the known sediment size, that is the bed materials. And definitely always remember, if the size of the bed materials, it should be in mm. Okay, if it is not in mm, then you have to convert into mm, and then you are going to find out the silt factor by this equation. Okay, f is equal to 1.76 root over d. D is nothing but your size of bed materials, or you can say size of sand. Okay, but it should be in mm. Okay, so if in the numerical your bed size is given in centimeter, then you have to convert it first into mm, and then you are going to substitute here. Okay, so this equation is valid when you substitute this d value in mm. Okay, so this is our first step. Our first step is to find out the silt factor by using this expression, that is f is equal to 1.76 root over d. Okay. Then next step is to find out the velocity. Second step is to find out the velocity. Okay, and you write down this expression. Okay, that velocity you are going to find out using this expression, that is vc is equal to qf square divided by 140 to the power 1 by 6. Okay, the second step is to find out the velocity by using this equation. Okay, so you write down this expression, qf square divided by 140 to the power 1 by 6 over. So here in the second step, we are going to find out the velocity using this equation. Vc is equal to qf square divided by 140 to the power 1 by 6. 1 divided by 6. So you are using this expression to find out the velocity in step number 2. Okay. So next step is to find out the area. So we all know area is nothing but discharge by velocity. So discharge is already known to you. Okay, and velocity we have calculated in step number 2. Okay, so in step number 3 you can find out the area. Okay, then in step number 4 you are going to use the expression for area of a trapezoidal channel. Okay, okay, then in step number 5, because in step number 4 the area expression, area is known to you, but your width of the channel, or you can say bottom width of the channel, and y value is not known. Z value, if it is given, then it's okay. If it is not given, then we are going to assume 0.5 or 1. Okay, so that in this equation we have two unknowns. One is width of the channel and one is your y value. So definitely with a single equation we cannot find out two unknowns. Okay, we need at least two equations to find out two unknowns. So that is why in the next step again we are going to consider the weighted perimeter equation of a trapezoidal channel. Okay, that is equal to twice y root over 1 plus z square plus b. Okay, but let's say we can also find out the weighted perimeter by this equation. 4.75 weighted perimeter is equal to 4.75 root over q. Okay. So what we are going to do in step number 5, first we find out the weighted perimeter by using this expression as q is known to us. Okay, q is known to us, so we can directly find out the weighted perimeter. And this weighted perimeter we are going to substitute in the expression of weighted perimeter of a trapezoidal channel. Okay, and then we have two equation and we have two unknown. One is width of the channel and one is depth of flow. Okay, then we are going to solve both the equations and we find out the two unknowns, that is your bottom width of the channel and depth of flow. Okay, so in the last step we are going to find out the bed slope using this equation. Okay, that is SB equal to f to the power 5 by 3 3450 q to the power 1 by 6. Okay, so you are kindly write down all the steps. Okay, because when you are going to solve numericals we have to follow step by step. Okay, Over. Okay. 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 So we move on to the numericals. Okay. First, we solve few numericals related to your Kennedy's theory, and then we solve numericals related to your Less's theory. Okay. I guess we have not solved any numericals related to Kennedy's theory. Okay. So first, we solve numericals related to your Kennedy's theory. Okay. Okay. So you write down the equation. Okay. Okay. So your first numerical is related to your Kennedy's theory. Okay. So you write down this question. It is design a trapezoidal channel by Kennedy's theory with side slope one horizontal is to one vertical in alluvial soil to carry a discharge of 30 meter cube per second in a bed slope of 1 by 5000, and then this is nk, coefficient of cutter is given 0.0225, and cvr is nothing but your critical velocity ratio, or you can also say it is mr. Okay. So you kindly write down the question. Okay. Over. So what is given? We have to design a trapezoidal channel by Kennedy's theory. Side slope is given one horizontal is to one vertical. That means Z is equal to 1. Okay, it's given. Z is equal to 1. Okay, then discharge is also given. How much? It's 30 meter cube per second. Okay, 30 meter cube per second. Bed slope is also given as b equal to 1 by 5000. Okay, then nk is given. Coefficient of cutter, that is 0.0225. Okay, so these are the given thing, and mr, or you can say critical velocity ratio, is given 1. Okay, so if you remember the steps, our first step is to, we have to assume a depth of flow. Okay, so we have to assume the depth. We all know it's a trial and error method. So in the first step, we have to assume a depth of flow. Okay, so in first case we have assumed 2 meter. Okay, I think you have already written the steps, so you can follow the step by step. Okay, the first step, we have to assume a depth. So in first case here we have assumed 2 meter. Okay, in the next step we need to find out the velocity. What is the equation for velocity? Is 0.55 multiplied by mr. This is nothing but your critical velocity ratio multiplied by y to the power 0.64. Okay, okay. So 0.55 multiplied by mr, mr is already given, that is your 1, okay, and multiplied by y to the power 0.64. So 2 is y we have assumed is equal to 2, okay, so 2 to the power 0.64. So calculate and see you are getting the same value or not. That is 0.857 meter per second. You are getting the same value. Okay. So the next step is to find out the area. As discharge is already given in the question, 30 meter cube per second, and then velocity we have calculated in the previous step. Okay. So we substitute here and we find out the area. Area is equal to 35 meters square. Okay. So in the first step we have assumed the depth of flow. Second step we have calculated velocity by using this equation, that is Vc equal to 0.55 multiplied by critical velocity ratio multiplied by y to the power 0.64. Okay. Then in the next step we are going to find out the area. So area is nothing but discharge divided by velocity. Okay. Okay. So in the next step, so definitely it's given we need to consider the channel shape is trapezoidal. Okay. Channel shape is trapezoidal and z value is given is equal to 1. Okay. Okay. So now we have to use area equation of a trapezoidal channel. Okay. Area equation of a trapezoidal channel. So area equation is nothing but b plus zy multiplied by y. Okay. So this is the area expression of a trapezoidal channel. Okay. So from this equation, area we have already calculated, that is 35 meters square. Okay. So width of the channel, this B is nothing but your bottom width of the channel. This is your B. Okay. This is nothing but your bottom of the channel. Okay. Plus Z is value is given, that is 1. Okay. And Y value we have already assumed as 2. Okay. So from this equation you can find out the width of the channel and see you are getting is 15.5 or not. Okay. 15.5 meter bottom width of the channel, 15.5 meter. over, you're getting the same value. Okay, okay. So next we are going to consider the weighted perimeter. Okay, so the weighted perimeter is nothing but b plus twice y root over 1 plus z squared. Okay, this is the weighted perimeter equation of a trapezoidal channel. Okay, so weighted perimeter equation of a trapezoidal channel. Okay, so in this equation, z value is 1, it's given. Y value we have assumed as 2. Okay, and then width of the channel we have just now we have calculated, that is 15.5. Okay, so find out the weighted perimeter. Okay, and then you find out the hydraulic radius. This is nothing but area by weighted perimeter. Okay, so first you find out the weighted perimeter value. Okay, then you find out the r value. Okay, because area we have already calculated, that is 35 meters square. Area is already calculated, that is your 35 meters square divided by the weighted perimeter. You calculate first by using this expression and then substitute here and find out the r value. And see, you are getting the r value is 1.6543 meter or not. Okay, this is your r value. Okay, so first you find out the weighted perimeter. They have skipped one step. Okay, so it's always better you first find out the weighted perimeter, then you find out the hydraulic radius, and see you are getting the same value or not. Getting 1.65. Okay. Okay, fine, fine. Okay. So now we have to find out the velocity. Okay, you have to find out the velocity again. So I think you have that equation for velocity. V is equal to, okay. So this is the equation. 23 plus 0.00155 divided by your base slope plus 1 by nk. Nk is nothing but your cutter's coefficient. Okay, divided by 1 plus again bracket 23 plus 0.00155 divided by base slope and then whole multiplied by nk divided by root r. Okay, and the whole term is again multiplied by root over r into base slope. Okay, so this is the equation for finding velocity. Okay, so you use this equation and again you find out the velocity and see how much you got. It will be approximately 0.89. Okay, meter per second. Okay, so here nk value is already given, base slope is also given. Okay, r value we have already calculated. Okay, so you substitute here and find out the velocity and see you are getting the same value or not. Getting the same value, 0.89 meter per second. Okay, so once you solve that velocity equation and you are getting the velocity as 0.89 meter per second. Okay, now we have to compare the velocity you have calculated in step number 2 and the velocity you have calculated just now. Okay, if both the velocity is same, then we can proceed. If both the velocity is not same, then we have to go back to our first step and we have to assume another value of y, or we have to go for second trial. So here in this case, if you see in the second step we got a velocity of 0.857 and in and the velocity you have calculated just now, we got 0.89. So these two are not same. Okay, so definitely your 0.857 is less than 0.89 meter per second. So what we are going to do, we are going for another trial, or you can say going for second trial, and assume the y value 2.2 meter. Okay, 2.2 meter. Okay, and then you continue till this step. Okay, so after solving this, you go back to the your step 1 and you change your trial value to 2.2 and repeat those steps till your velocity here. Okay, okay, then again we need to find out the velocity by that equation. 0.55 multiplied by critical velocity ratio multiplied by y to the power 0.64. Okay, so now here the y value changes, it's 2.2. Okay, so you are getting the velocity is 0.911 meter per second. Okay, 0.911 meter per second. Okay, then we need to find out the area. Okay, so this size is already known, so you can find out the area. Okay, once you find out the area by using the area equation of a trapezoidal channel, you can find out the width of the channel. Okay, okay, so once you calculate the width of the channel using the equation of a weighted perimeter, you find out the weighted perimeter, and after that you find out the r value, a by p. Okay, once you calculated the r value, again you use that equation, Cutter's equation for velocity, and you find out the velocity. Okay, so after you are finding the velocity, you will get, so this velocity you are going to get in step number 2. Okay, it is 0.911, and this velocity you are going to get using this equation. Okay, so these two are almost equal because this is corrected to two decimal point, 0.91 and 0.91. Okay, so you can say this is approximately same. Okay, so once this two velocity is same, then we can say that our assumed depth 2.2 is okay. Okay, so now our depth of the channel is 2.2 meter, and width of the channel is 12.77 meter. Okay, whatever the width you are going to get with respect to 2.2 meter. Okay, then we have to provide free board. Okay, so there are two situation. One is if it is less than 10 meter cube per second, discharge is less than 10 meter cube per second, then we are going to provide 0.65, and if it is greater than 10 meter cube per second, then we are going to provide greater than 0.75. Okay, these are the two conditions. What will be the free board? If the design discharge is less than 10 meter cube per second, then we are going to provide a free board of 0.65. Okay, if it is greater than 10 meter cube per second, then we are going to provide any value for free board which should be greater than 0.75. Okay, so that is why we have provided here 0.8 meter, and then this design depth will be 3 meter, and because of this 3 meter your design this width of the channel is also changing. Okay, so for that 3 meter depth you can find out the what will be the width of the channel by considering other terms as constant, okay, or as same. So this is the whole procedure how you can find out or how you are going to design a canal, or you can say for mobile boundary using Kennedy's theory. Okay, so this is quite difficult to solve manually, so we use some software called MATLAB for solving such complex numericals. Okay, where we have trial and error method, and where we can go for number of trials. Okay, if we go for manually, we can do only 2 or 3 trials, whereas if you use any computer application, we can go for number of trials, or because of this we will get more accurate value. Okay, which is manually it's not possible. Okay, so from exam point of view, if you are asked to design by using your Kennedy's theory, then maximum you go for 2 trial. Okay, you are getting the value or not doesn't matter. The process is matter. The step by step is matter. So you go for only 2 trial. Maximum is 2 trial. Okay. The first trial, if you got both the velocity is same, that is well and fine. Okay. If it is not same, then maximum you go for second trial. Okay, because we have time limit in the examination. Okay, so we are going to end today's class here. In tomorrow, sorry, in the next class we are going to solve some numericals related to Kennedy's theory as well as your Less's theory. Okay, thank you.